Hey students, just a few announcements before we start today's lesson. Don't forget our test Wednesday at 3:30. Don't be late or you won't be able to take it. Now, this stuff will not be on the test, but I strongly encourage you to study it until next week's test. Okay, let's start out with the obvious. Blood brings nutrients and oxygen to cells and needs to be carefully monitored and controlled. Blood contains particles of many different sizes and types. Cells, proteins, dissolved ions, and organic waste products that your body really doesn't need. Some proteins, like hemoglobin, they're essential for the body. But others, such as urea, which is a waste product from protein metabolism, you won't need to know that for your test. They must be taken out of the blood or they will interfere with normal metabolic processes. Blood passes through the membrane-lined tubes. So really, I just want you to study this picture for a little bit. You can pause the video whenever you need to and save pictures, and I know y'all can screenshot or whatever, but just make sure that you know the blood comes through the artery and it's going to go through all these tubes, which we'll go through in a minute, and then it's going to come back out. Well, then once it comes back in, it's going to come out through the urine, the ureter. I mean, it's practically the same word. It's going to be really easy to remember. Okay, and there's also three main processes involved in forming the urine. There's glomerular filtration, tubular reabsorption, and tubular secretion. Now, glomerular filtration is the ultrafiltration of plasma in the glomerulus, which, I mean, that's just a bunch of big words that pretty much means it's going down to the microorganism and it's getting everything out that doesn't need to be in there, just anything out of normal. And then tubular reabsorption is the transportation of substances out of the tubular urine. So whenever it's going out, back out to circulation. Tubular secretion is the transportation of substances into the tubular urine. So that's when it's coming out of the urine. I also want to go over some vocabulary words. Excretion is the elimination of toxins using urine. So this whole process, pretty much. Glomerular filtration rate, which I might also refer to later on as GFR, is the rate that plasma, which is in your blood, is filtered by the kidney glomeruli. This will be used for the test for kidney failure. So when you're testing, for kidneys and to make sure that everything's working properly, you're going to see how fast it's moving, because if it's moving too fast, it's not able to get all of your toxins out, and if it's moving too slow, it still isn't going to get everything out. Creatine is the end product of muscle metabolism. So, just that waste product, pretty much. The functions of the kidney are just the ways the kidney gets rid of unnecessary portions of blood. Think of your kidney as a conveyor belt. If it's going too fast, the workers can't get everything out. If it's going too slow, they're still not going to get everything, because, that's just boring. Who wants to do that, right? This is one way that kidney becomes dysfunctional. Renal blood flow is kept at a relatively constant, I'm sorry guys, I've got that on my iPad. Renal blood flow is kept at a relatively constant level, and that's a process called autoregulation. The two mechanisms that are responsible for this are myogenic mechanism, and I'm sorry guys, you gotta kind of bear with me on this word, tubuloglomerular feedback mekenism. These are all on my website. I'll be sure to give you all these words so that you know them. I'm really sorry guys, I know you're tired of this picture. We're just gonna go through this real quick. In the myogenic mechanism, an increase in pressure causes the blood vessel walls to stretch and opens stretch-activated cation channels in smooth muscle cells, and vice versa for whenever the pressure decreases. And in the tubuloglomerular feedback mechanism, since I'm having such a hard time saying that word, we're just going to call it TFM, okay? The transient increase in GFR, remember, glomerular filtration rate, is caused from an increase in blood pressure, and that leads to an increased NaCl, so sodium chloride, delivery to the macula densa, which is just another part of the kidney. We'll go through it later on. The events caused by this suggest that the purpose of the TFM may be to control the amount of sodium presented to distal nephron segments. And guys, a nephron is just the smallest, it's pretty much the most basic function of the kidney, and there's so many of them in the kidney. It's just one of the parts that helps through it. So these are all the main points to a kidney disease. So now we're going to go on to treatment options. So the most obvious choice would be a kidney transplant. So most people are born with 2 healthy and functioning kidneys, but they really only need 1. So of course there's requirement to whose kidney you can get, and just to make sure it'll function properly in your body. This is used mainly for younger patients who have more of a life expectancy. Older patients normally would not be the first ones to get this type of treatment. The older patients, or people who just really aren't expected to live that much longer, are gonna probably go for dialysis. And even in our study, the word dialysis is used in the kidney because your kidney does it, and that's just one of our vocab words, pretty much a verb when you're talking about your kidney. But when you're talking about treatment options, dialysis is pretty much the treatment itself. It's kind of to take the place of the kidney. Still, it's not ideal for long-term patients because kidneys work 24/7 and the dialysis machine doesn't. I really like this picture. It shows pretty much, mainly what's going on when you're getting dialysis. You've got a needle here and a needle here. It's going through here, and there's a blood pump, and it's kind of keeping it circulating. Heparin going in there as well. Dialyzer. That's when it's breaking everything down. It's getting all the toxins out. The air detector, you definitely need that in there. You don't want any air going back in. So, the pressure monitor is, remember we talked about certain pressures. You can't have too much and you can't have too little. So, this machine is pretty much got the mind that our kidney does. It does work fairly well. I mean, of course, it's not getting everything out, but it's better than having those toxins still in you. And while we're on that subject, let's talk about what happens when those toxins are in you. Of course, those toxins are going to try and get out of your body, or your body's going to try and push them out. They don't belong there. So they're going to try and come out through your skin and saliva and other parts of your body. When they're coming out, no part of your body wants it. So it's going to make rashes and, bruising. Your back might start to hurt because your kidney's now on overload. It's going to kind of swell up a little bit. You're going to be really sore. Your back's going to be sore because your kidneys are in your back. Your legs are sore. Your whole body just is starting to shut down after that.